Something is pulling our entire galaxy across the universe at nearly 600 kilometers per second, and for decades we had absolutely no clue what it was. Imagine driving a car with no windshield, foot jammed on the accelerator, and you can feel the speed, but you cannot see where you're headed. That's basically the Milky Way's situation. If we can't identify this cosmic tow truck, then what exactly happens when we get wherever we're going? A galactic pileup? Getting flung into a void? Or just becoming a snack for something we can't even observe? In the next few minutes, I'm going to walk you through the century-long detective story that led astronomers to something called the Great Attractor, and by the end, you'll understand why this invisible monster is both the most humbling and quietly terrifying discovery in modern cosmology. But here's the twist that still keeps researchers up at night. What if I told you we're not just being pulled, we're also being shoved by something even bigger lurking behind it? Now, to grasp the true scale of this mystery, we have to rewind to the 1970s, when astronomers first noticed something was seriously off with our cosmic neighborhood. They were measuring the motion of galaxies using the cosmic microwave background as a universal reference frame, and they found that the Milky Way and its neighbors were moving way faster than anyone predicted, almost like we're caught in a river current we didn't even know existed. At first, people thought, okay, maybe it's just some local gravitational anomaly, a cluster of galaxies with a lot of mass giving us a gentle tug. But as mapping technology improved and more velocity measurements came in, the numbers kept pointing in the same direction, toward the constellation Centaurus, hidden behind the thickest part of our own galaxy's disk. And this is where the story takes an almost frustrating turn, because the very place we need to look is blocked by an enormous wall of stars, gas, and dust, the Milky Way's own bright and cluttered center, which astronomers call the zone of avoidance. It's like trying to find a single blue house in a city while staring at the sun through a fogged-up window. For years, this region remained one of the biggest blind spots in the observable universe, and whatever was hiding there had enough gravitational oomph to yank hundreds of thousands of galaxies across millions of light-years. Now, you would think the next logical step would be to aim the biggest telescopes we have and finally unmask the culprit, but the universe decided to be difficult. Visible light gets absorbed and scattered by all that interstellar material, so traditional optical telescopes were practically useless. Instead, astronomers had to get clever and switch to radio waves and X-rays, which can slice through the dust like a cosmic X-ray at the airport. In the late 1980s and early 1990s, a team of researchers, including R. Brent Tully and others, started painstakingly mapping galaxy velocities across a huge swath of the sky. And that's when they realized the flow wasn't random. It converged on a single gravitational basin. They gave this invisible concentration of mass a name that sounds like a low-budget sci-fi villain, the Great Attractor. Personally, I find that name both wonderfully dramatic and perfectly accurate, because you can't look at the data without imagining a colossal cosmic whirlpool dragging everything toward it. According to the best estimates, the Great Attractor has the mass equivalent of tens of thousands of Milky Ways, all concentrated in a relatively compact region about 200 million light-years away. But here is the really unsettling part. When radio astronomers finally peered into the heart of the zone of avoidance, they didn't see a single monstrous supergalaxy or some giant glowing space monster. They found an enormous cluster of galaxies called the Norma Cluster, which is massive but not nearly enough to explain the sheer strength of the pull. This discovery opened a whole new can of cosmic worms, because it suggested the Great Attractor is not just one thing. It's a dense traffic jam of galaxy clusters, hot gas, and dark matter all working together to create a gravity well deeper than anyone imagined. And if you're wondering whether we're doomed to crash into it, scientists think we might never actually reach it because the universe is expanding and pulling everything apart at the same time, creating a strange celestial tug-of-war, where we keep moving toward the attractor but the finish line keeps moving away. Just when you thought the mystery was solved, the plot thickens in a way that still messes with my head if I think about it too long. In the early 2000s, a team led by astronomers studying the bigger picture realized that the Great Attractor itself is not the final boss. By zooming out and mapping galaxy flows over an even larger volume, they discovered that the Great Attractor is actually moving towards something far massiver in the constellation Shapley. They called it the Shapley Supercluster, a titanic collection of dozens of galaxy clusters that together holds the mass of about 10,000 Milky Way galaxies. And it sits beyond the Great Attractor, acting like a gravitational magnet behind a magnet. So in a weird, almost comical twist, our galaxy is being pulled toward the Great Attractor, which is itself being pulled toward the Shapley Supercluster, meaning the real driver of our cosmic motion might be something we didn't even identify
identify until relatively recently. I love this detail because it perfectly captures how science works. You find an answer, and immediately it reveals a deeper question. Some researchers even argue that there's a massive underdensity on the opposite side of the sky, a sort of cosmic void that is pushing us away as much as the supercluster is pulling us forward, making our galaxy feel like a confused shopper shoved behind in a crowded bazaar. This push-pull dynamic is still debated, but according to a major study published in Nature Astronomy, when you sum up all the gravitational influences within 1 billion light-years, the bulk flow that includes the Milky Way seems to be steered primarily by the Shapley concentration, with the Great Attractor acting more like a local way station on an intergalactic highway. So if you ever lie awake wondering what our place in the universe actually looks like, picture a tiny boat on a vast dark ocean, drifting along currents so enormous that you can't even see the shore. And somewhere out there, the mother of all whirlpools is slowly, patiently reeling us in. But wait, because the cosmic rabbit hole goes deeper than even the Shapley Supercluster. In recent years, some astrophysicists have proposed an even larger structure they call the Vela Supercluster, and there are whispers in the scientific community about something called dark flow, a controversial observation suggesting that entire clusters of galaxies might be marching toward a region beyond our observable horizon, possibly tugged by structures so unimaginably vast they exist outside everything we could ever hope to observe. Now, to be crystal clear, dark flow is not confirmed, and many experts think it could be a misinterpretation of data from the cosmic microwave background. But the mere fact that it's being seriously debated tells you how much we don't know about the architecture of the cosmos. What I find strangely beautiful about all this is that we are living on a tiny rock orbiting an average star, and yet we've managed to measure our own galaxy's speed with stunning precision, trace its trajectory across hundreds of millions of light-years, and identify a gravitational landmark we can't even directly observe. We mapped the invisible. That's the kind of achievement that makes me optimistic. If we can figure out something as mind-bending as the Great Attractor, imagine what else we can eventually understand. And the next time someone tells you you're going nowhere in life, you can confidently reply that you're hurtling toward a mysterious supercluster at 600 kilometers per second, and that's probably faster than anything they'll do today. Of course, none of this changes the fact that, in cosmic terms, our entire species and all our earthly problems are a blip, a brief flicker on a pale blue dot caught in a current we just learned to name. And perhaps the biggest question isn't what's pulling us, but what we'll discover when we finally map the full river, because every answer so far has only revealed that we are part of something far grander and more interconnected than we ever dared to imagine.